Um, Welcome to this deep dive. We're really thrilled to have you with us today.
Yeah, thanks for joining us.
So our mission for this journey is to explore how, ancient rock, colossal sheets of ice, and just the sheer force of deep time literally built an entire nation from the ground up.
Hmm.
We're talking about a place where geography isn't just, a backdrop for history. It operates as the actual primary architect of modern society.
Right, because the physical landscape of Sweden dictates almost every single aspect of life there. I mean, from the spatial distribution of agriculture to how they actually engineer their energy grid.
Yeah, totally. And to guide our analysis today, we're pulling from this really comprehensive source titled How Geography Shaped Sweden.
It's a fantastic document.
It really is. It lays out the geological, climatic, and cultural roadmap of the largest nation in Northern Europe. And we're going to be examining a region where the Earth is visibly rebounding into the sky.
Which is just crazy to think about.
Right. And mapping this invisible ancient coastline that still dictates modern land use, plus looking at a bustling city that is currently undergoing a forced physical relocation.
Yeah, because people often default to viewing geography as a static map, right? Like a fixed set of lines and colors. But this deep dive reveals a country that is highly dynamic. It's constantly shifting and evolving right under the surface.
Okay, let's unpack this. Let's start with the deep, ancient bones of the country. So Sweden's physical structure rests on the Fennoscandian Shield.
Yes.
And we were talking about one of the oldest and most incredibly stable geological formations on the planet. It consists primarily of ancient rocks formed during the Archean and Proterozoic eras.
Right, we're talking billion-year-old rock here. Billions of years of tectonic processes slowly shaped those ancient cratons into distinct geological provinces.
Like the Karelian and the Svekefenian regions.
Exactly, and the Smakana region too. These formations basically serve as the structural backbone of the entire Swedish landscape. And because this shield is just so old and structurally rigid, the region experiences negligible seismic activity compared to, active fault zones elsewhere in the world.
But that lack of seismic volatility doesn't mean the terrain hasn't been dramatically worn down over time.
Oh, not at all.
Over hundreds of millions of years, relentless erosion leveled the ancient bedrock. It created what's known as the subcambrian peneplain.
Mm-hmm.
So if you look at central and eastern Sweden today, you can actually observe this incredibly flat, smooth slate that was established long before any of the subsequent geological epochs.
Yeah, and while that bedrock is ancient, the visible landscape you actually navigate if you travel through Sweden today is remarkably young.
Right, young in geological terms, anyway.
Right. That topographical youth is entirely the product of the Pleistocene Ice Age, specifically the Huitzilolean glaciation.
The mechanics of that glaciation are staggering. I mean, we are talking about a continental ice sheet that was several kilometers thick.
Just a massive amount of ice.
Yeah, like a country-sized bulldozer. The sheer mechanical force and weight of that much ice moving across the land applied immense shear stress to the bedrock.
It literally gouged out deep valleys.
Here off the peaks of ancient rocks.
And completely redistributed the topsoil across the entire region. What's fascinating here is the distinct morphological evidence left behind when that ice sheet finally retreated.
It's like a messy footprint.
Exactly. The landscape serves as a geological archive of the melt phase. You have vast deposits of moraines, which are fields of glacial till.
That's that unsorted mix of soil, gravel, and boulders that just got dropped as the ice stalled out.
Yeah, just dumped there. And then you have the eskers, which are arguably the most striking features.
The eskers are super cool.
They really are. They're these long, winding, elevated ridges of sand and gravel. They're actually the inverse casts of ancient rivers.
That's such a wild concept to visualize.
It is. Basically, meltwater flowed under immense hydrostatic pressure through these tunnels right at the base of the glaciers, depositing sediment.
And then when the surrounding ice vanished, those riverbeds were left standing as raised embankments across the terrain.
You also find Dagir moraines. These are smaller, parallel ridges formed underwater right at the grounding line of the retreating ice sheet.
And these formations aren't just historical curiosities for geologists to look at. They fundamentally dictate modern drainage patterns.
Yes.
And they've historically provided dry, elevated routes for human settlement and roadways.
Absolutely. And understanding that glacial retreat unlocks one of the most crucial concepts in Swedish geography.
Yeah.
The highest coastline.
The highest coastline. This is the ultimate aha moment for understanding Sweden.
It really is. As the ice melted, global sea levels surged, flooding inland areas. The highest coastline marks the maximum post-glacial marine limit.
So if you were analyzing human settlement patterns in Sweden today, that invisible ancient waterline is the defining variable.
Right, because below the highest coastline, the energy of ocean waves sorted out the glacial debris.
The water basically washed away the lighter, finer sediments, right?
Exactly, allowing them to settle into deep, rich clay soils in the valleys. Today, those clay plains are the foundation of Sweden's most productive, thriving agricultural sectors.
But then above that post-glacial marine limit, the terrain tells a completely different economic story.
Completely different.
Because that soil was never sorted by wave action, it remains this chaotic, rocky mix of glacial till.
Which is highly unsuitable for large-scale agriculture.
Yeah. Consequently, the landscape above the line is dominated by vast boreal forests. If you overlay a map of the modern Swedish timber industry onto a map of their agricultural zones, you are essentially tracing the ghost of a prehistoric ocean.
It's a striking demonstration of how ancient climatological events hardwire modern economic capabilities.
Here's where it gets really interesting. We mentioned earlier that the Earth in Sweden is visibly rebounding.
The bouncing Earth.
Yeah. The scientific framework for this is glacio-isostatic rebound.
And the physics behind it are actually quite elegant. The continental ice sheet was so massive that its weight physically depressed the Earth's lithosphere down into the viscous mantle below.
It just squished it down.
Squished it right down. And when the Weichselian glaciation ended, that crushing overburden was removed. The mantle has been slowly flowing back ever since, pushing the crust upward.
And the scale of this uplift is localized but profound, particularly up in the high coast, or Högakusten, in northern Sweden. Since the ice melted, the land there has risen by hundreds of meters. If you were to hike the high coast today, you'd find ancient sea beaches.
Complete with sand and marine shells.
Yeah, stranded high up on the hillsides, hundreds of feet above the current water level.
Because mantle viscosity is relatively high, this is an ongoing real-time phenomenon. The land is still rising by several millimeters a year.
That's wild.
It really is. In the Kvarken archipelago, the uplift is actively altering the geography. Former sea bays are gradually pinching off from the Baltic, transitioning into shallow wetlands, and eventually becoming freshwater lakes.
So entirely new islands and peninsulas are continually emerging from the sea.
Yes, requiring navigational charts to be periodically updated just to reflect the expanding landmass.
Just incredible. So this dynamic geology provides the foundation for how the country is geographically and economically organized into three distinct realms. Let's examine the northernmost region first, Norrland.
Norrland.
It encompasses roughly 3/5 of Sweden's total land area. It is characterized by the Scandinavian mountains along the Norwegian border, culminating in Sweden's highest peak, Mount Kebnekaise.
Norrland operates largely as the nation's raw resource engine. While it is sparsely populated, its geography consists of expansive boreal forests, deep river valleys, and significant mineral deposits.
It's the primary zone for resource extraction.
Exactly. It provides the timber, iron ore, and hydroelectric potential that basically fueled Sweden's industrialization.
Then moving south, you transition into Svealand. This is the central fulcrum of the country, featuring the central Swedish lowland.
Right. It's a fault block landscape that creates a highly fertile, relatively flat corridor stretching from Stockholm in the east all the way to Gothenburg in the west.
So Svealand basically functions as the administrative and demographic core.
Yes, the geography naturally facilitates infrastructure, making it a highly efficient agricultural zone and the primary east-west transportation artery integrating the country's domestic economy.
And then further south is Gotaland. This region presents a geographic duality. You have the Småland highlands, an elevated plateau characterized by poor, rocky soil and dense woodland.
Right.
But at the southernmost tip, you find the Skåne Plain.
And the Skåne Plain is geographically and geologically much closer to continental Europe than the rest of Sweden. It features sedimentary rock and incredibly rich topsoil.
Which makes it the most intensively farmed region in the country.
Absolutely. Gotaland is also defined by the Øresund Strait, a critical maritime choke point. The construction of the Øresund Bridge across that strait permanently altered the economic geography of the region.
It seamlessly integrated southern Sweden with Denmark and the broader European market. A unifying element across all three of these regions, though, is the sheer density of inland surface water. Sweden contains roughly 100,000 lakes.
100,000.
Yeah, integrated with a massive network of rivers descending from the Scandinavian mountains eastward into the Baltic Sea and the Gulf of Bothnia.
That hydrological network is a cornerstone of the Swedish economy. Historically, these rivers served as the logistical arteries for the timber industry, allowing log trees to be floated directly down to coastal sawmills.
And today, they form the backbone of the national energy grid. Hydroelectric power exploits the topographical drop from the mountains to the coast.
The Lule River is a prime example of this engineering. The system captures the massive influx of seasonal spring snowmelt in upland reservoirs.
And then they carefully manage the release of that water through a cascade of turbines.
Exactly, generating peak electricity during the dark, freezing winter months when domestic power demand is at its absolute highest.
The lakes themselves also serve specialized economic and infrastructural roles. Take Lake Vänern, for instance,
It's huge.
the largest lake in the European Union outside of Russia. Its scale, combined with lock systems like the Trollhätte Canal, transforms it into a major inland shipping route and sustains large-scale commercial fisheries.
And then you have Lake Vättern, a deep rift lake, which provides massive reserves of crystal clear drinking water.
Lake Mälaren completes that hydrological core, functioning as the primary freshwater supply for the entire Stockholm metropolitan region.
Right.
But to understand the flow of all this water, we have to look at the atmospheric conditions. Given that a large portion of Sweden sits above the Arctic Circle, you probably assume it's just a persistent permafrost environment.
Most people do, but the thermal anomaly that prevents that is the North Atlantic Current. It is an extension of the Gulf Stream that transports warm, tropical marine water across the Atlantic and channels it right along the Scandinavian Peninsula.
So the heat exchange from this current fundamentally disrupts the latitudinal expectation.
Exactly. It keeps the coastal waters largely ice-free and raises the ambient air temperature significantly higher than equivalent latitudes in, say, Canada or Russia.
But the climate is still highly stratified due to the country's north-south orientation. In Götaland, down south, you find a temperate oceanic climate with relatively mild winters and warm summers.
Then as you move into Svealand, it transitions to a humid continental climate. The winters become noticeably harsher.
And by the time you reach northern Norland, you are in a subarctic zone. Prolonged, severe winters and brief, intense summers.
The latitudinal position also creates extreme variations in solar insolation. Near and above the Arctic Circle, the tilt of the Earth creates the midnight sun during the summer solstice.
Where the sun remains continuously above the horizon.
Right, and the inverse is the polar night in winter, plunging the region into extended darkness. This dramatic photoperiod dictates agricultural growing seasons, biological rhythms, and even social behavior.
It's an environment defined by its borders, particularly at the eastern boundary, the Baltic Sea. The hydrology of the Baltic is highly distinct because it is a brackish basin. It receives a massive influx of fresh water from the Swedish and Finnish river systems, while the narrow Danish straits severely restrict the inflow of highly saline water from the North Sea.
And this low salinity environment creates a really unique, highly specialized ecological niche. You find a distinct biological overlap where marine species, like cod and herring, have adapted to survive right alongside freshwater species like pike and perch.
The coastal interface with the Baltic is also incredibly rugged, featuring archipelagos comprising tens of thousands of islands.
Especially the vast clusters protecting Stockholm and Gothenburg.
Yeah, these island chains create sheltered navigational channels and unique microeconomies.
Yet the islands of Gotland and Öland diverge completely from the granite and gneiss of the mainland shield.
They're totally different geologically.
Completely. They are composed primarily of sedimentary limestone, resulting in karst topography.
Gotland is famous for its rocks. These towering, isolated limestone pillars that have been chemically and mechanically weathered by the Baltic waves into intricate, almost alien formations.
And on Öland, this limestone geology manifests as the Great Alvar. It is a massive, flat limestone pavement with incredibly thin soil profiles.
It looks barren, but it actually supports a highly specialized, rare ecosystem of drought-resistant flora that even earned it a UNESCO World Heritage designation.
Right. Contrasting the bare limestone of Öland, roughly two-thirds of the Swedish mainland is blanketed by boreal forests, predominantly spruce, pine, and birch.
It's one of the most heavily forested nations globally.
Supporting robust populations of apex predators and large herbivores like wolves, lynx, and moose.
The timber industry extracts immense wealth from these woodlands, making Sweden a top global exporter of pulp and paper. But the regulatory framework prevents unchecked exploitation.
Yes.
Strict forestry laws mandate comprehensive replanting after harvests, ensuring that the total volume of standing timber is actually increasing year over year.
Yeah. That legislative approach really reflects a broader cultural relationship with the geography, codified in the principle of Allemann's Retten.
The right of public access.
Exactly. This legal tradition grants individuals the freedom to roam, hike, forage, and camp even on privately owned land, provided they do not disturb the ecology or the landowner.
It embeds a deep-seated environmental awareness into the cultural fabric.
It does. And this conservation ethos is further formalized in their national park system.
Like Sarek National Park in the far north, it protects vast tracts of alpine peaks, glaciers, and deep valleys without a single marked trail.
Prioritizing raw ecological preservation over tourist accessibility.
And Abisko National Park leverages its specific rain shadow microclimate to provide some of the clearest skies in the world for observing the aurora borealis.
The spatial geography of the North is also deeply intertwined with the indigenous Sami people. Their cultural geography and economic livelihood are historically centered around reindeer herding. This practice relies on transhumance, which is the seasonal migration of herds between the high alpine pastures in the summer and the lower boreal forests in the winter.
Where the reindeer graze on specific lichens under the snowpack.
Exactly.
But the modern geographic reality is that these traditional migration corridors are increasingly fragmented. The expansion of commercial forestry alters the composition of the winter grazing lands. Furthermore, the physical infrastructure required for hydropower, wind farms, and particularly mining intersects directly with these ancient roots,
creating complex spatial conflicts between traditional land use and industrial economic development.
And the sheer scale of that industrial development yields some profound geographic consequences.
Yeah.
The most dramatic example of this tension is the city of Kiruna in the far north.
The moving city.
Yes. Kiruna functions as a critical hub for European resource extraction, sitting directly adjacent to the largest underground iron ore mine on the continent.
The extraction has been so extensive and has gone so deep that the geological integrity of the bedrock beneath the city center has been compromised.
The ground is literally experiencing subsidence. It is caving into the void spaces left by the mining operations.
Rather than abandon the ore or risk municipal collapse, the response has been an unprecedented urban engineering project. They are physically relocating the entire city center,
Moving historic structures building by building.
and shifting the population to stable ground a few kilometers away. It is a stark example of the tension between geography and modern industry.
Showcasing the drastic logistical measures required to sustain resource extraction in a fragile topography.
Truly.
So what does this all mean? When you synthesize all these elements from the source material, the definitive takeaway for you, the listener, is that geography is not an inert stage. It is an active, ongoing process. Analyzing Sweden's terrain provides a masterclass in human adaptation. They have engineered their society to harness the spring snowmelt for their power grid, built a highly regulated timber economy on glacial till, and physically moved urban centers to accommodate the earth beneath them.
That adaptation is currently facing unprecedented environmental pressures, though. Because of the polar amplification effect, temperatures in the high latitudes are rising significantly faster than the global baseline.
Which is a huge concern.
This thermal shift threatens to destabilize the delicate boreal ecosystems, alter the hydrological cycles of the snowmelt, and disrupt the specific microclimates that govern the region.
Additionally, the unique brackish ecosystem of the Baltic Sea is severely threatened by eutrophication.
Nutrient runoff from the fertile agricultural plains in the south triggers massive algal blooms, which subsequently deplete the oxygen levels in the deep water basins.
Creating expanding dead zones.
Exactly.
It is a meticulously balanced geographic system that is now operating under immense compounding stress.
This raises an important question. We discussed the glacio-isostatic rebound lifting the northern landmass. In the north of Sweden, the bedrock is currently rising fast enough to act as a localized countermeasure to global sea level rise.
The land is literally outstripping the oceans.
However, in the southern regions, that crustal uplift is negligible, leaving the vital agricultural and population centers highly vulnerable to coastal inundation.
Right.
As eustatic sea levels accelerate exponentially over the coming decades, how will this slow-motion geological race between the melting of the global ice caps and the upward thrust of the ancient Fennoscandian shield fundamentally redraw the topographical and political map of Northern Europe in the centuries to come?
The very tectonic plates they rely on are racing against the rising tides.
Yeah.
It's a fascinating thought to leave on. We want to thank you for joining us on this deep dive today.
It's been great.
It has been an incredible journey unpacking the geographical forces that built and continue to shape the landscape. Until next time, keep analyzing the terrain and keep exploring.